All right, so you're welcome to this class. We'll be looking at the modern Fortran course. This is the part 2. The second class we'll be having on this course. All right, so basically, um, we'll be proceeding with other core aspects of the course, and of course the exam focus areas. All right, so if you can hear me, if you can see the screen, just type in the comment box. I can see and I can hear. All right, I need your comments right away so we can proceed with immediate effect. All right. Good evening, Bethel, Austin, Njoko, Oluwa Bukolami, Agunbede. Okay, I can see your responses. All right, beautiful. So now quickly, like I said, we'll continue with major aspects of the course that cannot be ignored, and of course these areas are very crucial. Okay, in our last class we looked at modern Fortran, we looked at formula translation. Okay, so basically we are going to be starting with the basic structure of modern Fortran. All right, we'll start with the basic structure of modern Fortran. Basic structure of modern Fortran. Okay, so this is what we'll be commencing with. Basic structure of modern Fortran. Okay, as much as modern Fortran is important, it's also necessary, it's also essential to know the basic structure of modern Fortran. Very, very important to know that. Okay, so basically I'm going to be giving you the form of which modern Fortran can be represented. So we have it begins with the program. It begins with the program. Okay, then of course then program name. Okay, then after program we have the implicit none. Then we also have the specification part. Okay, then we also have the execution part. Then we have the subprogram part. Then of course we have the end program parts, which happens to be the last part. End program. Okay, and of course the program name. Okay, so someone is asking, does the different colors of pen mean anything? No, it doesn't. It's just my way of actually representing it. So it does not mean anything. Okay, so you don't have to use different colors of pen. So this is the structure, the basic structure of modern Fortran. All right, this is the basic structure of modern Fortran. Okay, all right. So first of all, like I said, we have the program, which happens to be the program name. The program, you write program, then the name of the program, then implicit none. Then we have the specification part, we have the execution part, we have the subprogram part, we have the end program, which then of course followed by the program name. So I'm going to be explaining every segment, every aspect of this basic structure of modern Fortran. I'm going to be explaining every aspect of it. Okay, every aspect of it, because they all have their various meanings and they have their various significances. All right, they have their various significances. Okay, so basically, having all of this, I'm going to be treating them one after the other. Okay, one after the other. So okay, all right. So we have the program name. Okay, so basically, one thing that is very important to understand is that the program must have a name. Okay, that's why we have program name, and the program must have a name. So you have to start a program just like you want to organize an event. Okay, the event must have a name. Okay, the event must have a name. I don't know, can you hear me? Can everyone, if you can hear me, say I can hear you. If you can see the screen, you say I can see the screen as well. If you can see and you can hear, please type I can see and I can hear. So we'll proceed. I'm trying to explain each of these, but I need to be sure that everyone can hear and can also see the screen. All right. Okay, so let's proceed. You can hear and you can see. Beautiful. So now let's proceed. Okay, so like I said, begin with the program. Every program has a name. Okay, every program must have a name. Okay, and that's why we have the program name. Then, like I said, implicit none. Implicit none is actually a relevant aspect of a Fortran program. What implicit none is that it does is that the implicit none forces the programmer to declare all variables. All right, to declare all variables. That's what implicit none does. So now let's take for instance that we have a formula like this: F equals to ma. This mass and acceleration. The variables here are F, M, and A. That's what we mean by variables. Variables are more like letters where you can actually store values. All right, letters where you can store values. Okay, so it's a storage area where values can be stored. So a variable must have a data type, but we'll be coming to that. So, but implicit none should be noted, okay, to be a major aspect of a Fortran program that forces the programmer to declare all variables. All variables, not some, all. That's what the implicit none plays as a role. That's the role it plays. Now, what happens? So how about the specification part? So the specification part is where we declare. So the specification part is where variables are declared. All right, that's the specification part where variables are declared. Where variables are declared. That's the specification part. That's where variables are what? Declared. The implicit none is just like a commander that gives the command, say declare all variables now. Then the specification part is where we now declare the variables. That's the specification part. Okay. Now someone is asking if it's CBT. Yes, it's a CBT examination. It's CBT, computer-based test. All right. So moving forward, like I said, specification part is where variables are what? Are declared. Then now we also have the execution part, which is this third part you're seeing here. So what happens at the execution part? So it's very important to know every relevant function of these different parts of the basic structure of modern Fortran. So the execution part is where we declare executable statements. Okay, where all executable statements are actually used, where we use all executable statements and even non-executable statements as well. All right, so it's where we use executable statements and non-executable statements. So like I said, executable and non-executable statements are declared here, or they are used here. This is where they are used, executable and non-executable statements in the execution parts. All right, so it's very important to note that. Okay, in the execution parts where we use executable and non-executable statements. Okay, so that's the third. Then we have the fourth one. So the fourth one is what we call the subprogram. The subprogram part. Subprogram parts. So in the subprogram part, like I said, I'll be giving examples of all of these, but just take note of their functions, the functions of each of these parts. Executable and non-executable statements are used in the execution part. Okay, variables are declared in the specification part. Implicit none forces the programmer to declare all variables. Then the program name is of course what the program stands for. Now the subprogram part is actually known as the part, okay, that uses what we call subroutines. Okay, uses what we call subroutines. These subroutines and subprograms are written in this subprogram part. Now in complex types of programs, we use subroutine and subprogram, not for simple ones. I'll explain it as we proceed. So I want you to take note of all of this. All right, then another thing you must take note of is the end program part. So any program that starts would also be required to end. Now if you look at this program name, you realize that there's an underscore here, which means, what it means is that a program name has to be together. That is, it should not be spaced. For instance, now if the name of a program is University of Port Harcourt, you want to write name of a program University of Port Harcourt, you will not say university, you will not write it like this, University of Port Harcourt. You won't write it this way. Okay, you won't write it this way. Rather, this is how you write it. You say university underscore of underscore port underscore then what Harcourt, like this. This is exactly how it will be written. Okay, this is exactly how it will be written. So basically, like I said, it's very important to note that. It's very important to note that. So if you have a program name that is not one word, you must use an underscore. There should be no space in your program name. And the exact program name that you used in beginning your program should be the exact program name that you'll be using in ending. All right, don't use different program names. All right, don't use different program names. So it's very important to take note of this. All right, so now one thing you need to understand is that I've been mentioning statement all this while. All right, so what then is a statement? Okay, so the simplest definition of a statement is an instruction that performs a logic. So any instruction that performs a logic is called a statement. Any instruction that performs a logic is called a statement. All right, so now, and of course, statements can be, if you look at what I wrote here, executable and non-executable statements. So we have those are the two types of statements. It's either the statement is executable or the statement is non-executable. Okay, so when we say executable, it means that it can produce an output. Non-executable cannot produce an output. That's what we mean. So a statement that can produce an output is called an executable statement. A statement that cannot produce an output is called a non-executable statement. All right, it's very crucial to understand that. Okay, so now moving forward, we are going to be looking at variables. So we're going to be looking at variables. Okay, variables. I know I talked about variables, much earlier. All right, but I'm going to be explaining variables. I'm giving you the data types of variables. So like I said before, a variable is a name given to a storage area. The keyword here is what? Storage area. So a name that is given to a storage area, okay, where values can be stored. Values stored. So these are the three keywords. Storage area where values can be what? Stored is called what? A variable. It's called a variable. All right, so I want you to take note of that. All right, so like I said, a variable must have a data type. A variable must have a data type, a way of actually representing it. So a way of actually representing it in a program is the exact data type. So not all types of variables, not all variables can actually be used in different or in all kinds of programs. Not all variables can be used in all kinds of programs. Some variables are designed specifically for specific programs, not all. So that's why we have what we call data type. And now, so I'm going to be giving you the 5 data types of variables and of course their descriptions. So now we have data type, then we have description. Now the first data type I'm going to be giving you is what we call real. All right, real data type. What does it do? When we say description, what is its function? So it holds floating point numbers. So it holds floating point numbers. That's the function of the real data type. So it holds floating point numbers. That's the function of the. So when we say floating point numbers, we are talking about like decimals. We are talking about basically numbers that cannot terminate. Numbers cannot terminate. Even numbers that can terminate, but in decimal forms or fractional forms. So real floating holds what? Floating point numbers. Then number two is what we call integer. All right, so it's what we call integer. So integer holds integer values. So we say it holds integer values. So that's the function of what? Integers. It holds integer values. So the real holds floating point numbers. Integer holds integer values, like whole numbers. Whole numbers are integer values. Okay, 1, 2, 3, 4, 5. Even 0 is an integer. Okay, 0 is an integer. -5 is an integer. Negative values are integers. Positive values are integers. 0 is also an integer. All right, so that's number 2. Now number 3 is what we call complex. Okay, so it's what we call complex data type. Now what's the function of the complex data type? So it's used to hold what? Complex numbers. So it holds complex what? Numbers. That's the function of the complex what? Data type. All right, then number 4 is what we call logical. So what does logical do? Logical stores what we call, or it holds what we call logical Boolean values. Now these Boolean values are logics. Okay, they are logic statements like true, false, okay, and, not. So these are called Boolean values. All logical values are called what? Boolean values. All right, Boolean values. So it's very important to note that. Then the last but not the least is what we call character. Is the character data type. That's the last but not the least. So what does the character data type do? So it holds what we call characters or strings. So it holds characters or what? Strings. So what are characters? Characters are usually statements, letters. All right, letters, not values. So the data type that holds statements or sentences is what we call the character. Okay, so it's very important to know that. So it holds characters or strings, so you must know that. So these are the five data types for variables. All right, so now I'm going to be showing you how to declare these data types. Like I told you, I said we have real, we have integer, we have complex, we have logical, and we have the what, character. All right, so these are the five what, data types. These are the five data types. Okay, these are the five data types. Okay, so I'm going to teach you now how to declare variables, what we call variable declaration, how to declare variables. Okay, but before we go to how to declare variables, I want to be sure that you can still hear me and you can still see my screen. All right, so can you still hear me and see the screen? Can you still do that? If you can still do that, say I can still hear you and I can still see the screen. All right, good. Okay, so you can still hear me and you can still see my screen. Perfect. So let's continue, since we are on track. We are actually progressing. Okay, so the next thing, like I said, like I said, we'll be looking at is what I call, or what we call variable declaration. Variable declaration. So how can we declare variables? Now, the general form for declaring variables is, first of all, the type specifier. Okay, then the variable name. Okay, so the type specifier, that is the data type. Then we put dots like this, dots, like double columns like this. Okay, exactly the way I'm writing it. Then after that is the variable name. All right, now remember, if we are declaring, even if it's an example, don't have space, so we put underscore there. Okay, so this is actually the general form. Okay, so for instance, now for example, now we want to declare integer. Okay, so we'll say the type specifier is integer. All right, so we say integer, then like this. Then for instance, now total is a variable name. All right, it's a variable name for an integer. You can actually have the total of numbers and it gives you 50. 50 is an integer, so total. Okay, so another, let's say real, you want to declare real. You can have something like let's say average. Average is, for instance, now you want to solve for the average and get, let's say, 5.62 as an average. Usually when we are solving averages or means, we tend to most times or sometimes get decimals. Okay, sometimes total, when we add most values, total can actually be an integer, total can still be a real, average can be an integer, average can still be a real. But what I'm just saying, these are just examples. Then now complex data type. We use something like CX. We say CX. Okay, CX. All right, CX or complex. This is the variable name. Okay, then we have logical. Remember, I told you that logical stores boolean values. All right, boolean values like the true, dot false. Okay, the true, dot false, and all of that. So usually logical values tends to give logical statements that have to do with completions. Okay, that have to do with completion. So basically, it focuses on, let's say, decisional statements. When you're trying to make decisions, like for instance, true or false. Okay, or, and, not. Those are logical examples. All right. And so let me say a variable name can be, let's say Dawn. Okay, let's say Dawn, for instance. Okay, but one thing you need to understand is that these are just examples. These are just examples. All right. Then now we have character. Character. Okay, character the variable name can be a message, because now if you have a message, for instance, now, or a text, usually a text is not one word, and I told you that characters stores character or strings, like statements, like sentences, okay, like sentences. So we can have something like Obi is now a man. This is a sentence. Obi is now a man. This is a what? Sentence. Okay, this is a sentence. All right. Someone is asking me to please recap the variable. You can refer back. Okay. Is there any other person who is having network issues? I believe you can hear me clearly, right? So anyone who is having network, when your network is stable, you can always go back to watch the video. Okay, so I believe it's clear. I believe you can I'm very clear and audible to some of you, right? I'm very clear and audible, and it's not like the screen is lagging or anything, right? Okay, all right. So now let's continue. Let's proceed. Okay, now moving forward, how do we assign values to variables? Okay, so we assign values to variables using equal to. After declaring, it's important to assign. So we assign using equal to sign. All right. So for instance, now want to assign a value to this variable total. So what do? We say what? Total. Okay, but instead of putting this, we'll put equal to. Okay, total, let's say 2000. Then let's say want to assign a value to average. Okay, so we can say average equals to, let's say 16.667. all right. Then done equal to dots true. Since this is logical, it means that we have to use an example of a logical type. All right. So if you want to now assign value now to, let's say, message. Remember, messages, this message was under what? Character. It was declared as character, right? So we have to put equal to, and it has to be a statement. Okay, we can say something like let's say welcome from the holiday. All right, and it has to be in quotes. Okay, then let's say want to example of a complex. Now let's say now CX complex, like complex numbers. This can be, let's say 3 points. Let's say we have 3.0 plus 5.0i. all right. Remember how complex numbers are. We have the real part and the imaginary part, right? So these are like examples of values that are assigned to the various variable names. Okay, so these are examples. All right, so quickly we'll be looking at another one. We'll be looking at, we have looked at variables, so the next one we're looking at will be constants. Looking at constants right away. All right, looking at constants right away. So constants are quantities whose values do not change during program execution. Okay, so these values, they do not change during program, when you're trying to execute a program. All right, so any data
object, any data at all, any value at all that will not change is a constant. So constants we can have real constants, we can have integer the same way we have real variables, integer variables, complex variables, logical. That's also how we have constants too. All right, so like I said, we can have integer, we can have integer constants, can have integer constants, can have real constants, can have complex constants, we can have logical constants, and we can have character constants. All right, character constants. So an example of an integer constant is of course, let's say 2, 3, 4, 5, 6, 7. These are like integer constants. Okay, these are integer constants. Okay, real constants can be like a constant that is real, like pi. Pi is 3.14142. It's a real constant, right? Then we also have complex. A complex constant can be let's say minus 3.0 plus 4.5i. So logical constant example, like we have true or dot false. Character constants can be the one character constant. Let me use the one that is very, very popular. Hello world is a character constant. So constants are just like fixed entities that cannot be changed. So it's not the same thing as assigning value. You can assign any value at all, but you see constants do not change. You cannot use one constant to replace the other. For instance, now you cannot use 3 to replace 2 because 2 and 3 are not the same. You cannot use 4 to replace 6 because 4 and 6 are not the same. You cannot use 9.0 times 10 raised to power 9 Newton meter square per coulomb square. That's Coulomb's constant, that key in Coulomb's law of electrostatics. You can't use this to represent pi because they are entirely different. This is a different constant from this one. Okay, this is a different constant from this constant. So it's very important for you to actually understand constants and their examples. Okay, all right, so that's very relevant. Okay, that's very relevant. So we'll be going to writing programs. We'll now be looking at writing simple programs. Okay, but I need to be sure that you can still hear me. If you can still hear me, say I can still hear you. I'm sorry for the repetitions of whether you can hear me, but I need to know that you can hear me so we can proceed. So I'll be sure that my network is stable. All right, so if you can still hear me, type I can still hear you, sir. Please do that so we can go to the next segment. Now we will now look at basic input and output statements and how to write simple Fortran programs. All right, good. I've gotten one response. Okay, you can still see the screen. Good, nice one. Okay, all right, just one person has responded that person can still see and can still hear. I need more responses because we'll be looking at basic input and output statements now. All right, we'll be looking at basic inputs and output statements. Basic input and output statements. Okay, that's what we'll be looking at right away.
Basic input and output statements.
All right. So now quickly moving forward. Now if you look at this, all right, we have input, we have output. So basic input and output statement means that we have both input and we have output statements. So now we are going to begin by looking at input statements. We are going to be looking at input statements first. That's what we are going to be looking at first. All right. So now when we say input statements, what do we actually mean? All right, from the word input, okay, input, then output, but we'll look at input first. So basically an input statement is actually a statement that is used to bring data into a computer program. So it is a statement that is used to introduce or bring data into what? A Fortran program or a computer program. From the word input, bring in, input, put in. All right. So it, like I said, input statements are statements that are used to bring data into a computer program. So basically, one thing you need to understand is that Fortran uses reads. That is READ, not real, reads. Fortran uses read as its input statement. That's what Fortran uses as its input statement. It uses what? Read. Now, along the line, you would be made to understand what read is, how read can be used, how read performs, how read can be utilized as an input statement. Okay, so now that brings us to the read statement. Read is capital letter, so read statement. That brings us to read statement. So the read statement is an executable statement. Okay, that is an executable statement. I told you that an executable statement performs an activity that causes an output to be generated. Okay, so executable statement leads to executions from the word executable. Okay, so like I say, the read statement is an executable statement. It's an executable statement. All right, so it what it does is that it causes the Fortran compiler to do something. It makes the Fortran compiler to actually perform an activity. Okay, so like I said, an activity for execution to be done, from the word execution, you know that an action must take place. Non-executable, an action does not really take place. All right, so basically the read statement has a general form. Okay, and this general form can actually be represented in two ways. I'm going to now, the first way of representing the read statement is that, now remember I told you that read must be in capital letter. So you say read, then there's an asterisk at the top. I'm going to be explaining what these things mean. Then comma, then you have what we call variable or list of variables, or list of variables. All right, or list of variables. So this is the general form of the read statement. Okay, of the read statement. Or we can also have it represented like this. It can also be read, then bracket d comma f, then we have what? Our variable, or what? Lists of variables. I'm going to be explaining this in a way you would actually understand. All right, I'm going to be explaining this in the way you actually understand. Now this D you're seeing here is called the device code number. The device code number. Every device that is used to run a program has a code. So D is called the device code number. Now F is called the format. Format means the method or the type of steps that are actually employed, the pattern, the nature. When we say format, the nature, the pattern, the algorithm. So the F is called the format specification number. That's what F is called. D is called device code number. F is format specification number. Now this device code number is used to actually recognize your computer device. Like I told you, every computer has the device code number. So device code number is not constant with all computers, but it varies from computer to computer. All right, so and most times it's based on the installation. Now the software installation can change the device code number. Sometimes you can even upgrade the computer to a given level that would enable it to actually have a specific device code number. Okay, so it's very important to know that. So basically, supposing now you see 5 or 11, okay, as your device code number, okay, and your computer rejects it, what you have to do is to simply replace it with this asterisk. That is, if you see 5 or 11 as your device code number and you try to input it here and the computer rejects it, all right, so just use this asterisk. It will run, the computer program will run. Okay, this is actually a very practical aspect that would have required us to employ a couple of practicals. Okay, now probably in the nearest future we'll look at practical aspects. I'm planning a seminar on data analysis, which would also involve some computer programs, some trainings on how to actually program, okay, using different languages. We have the Python, okay, we have other data analysis softwares like Power BI, SPSS, and all of that, JavaScript, okay. So like I said, don't forget the device code number is unique for a particular device. I say if it does not work, if you look at these two methods of actually declaring this read statement, we have this or this. All right, then like I said, format specification number now is actually the way you want your input to be arranged, like the pattern. I want your input to be arranged into your device, okay, into your device. Now for instance now, let's say we have something like we have read now, then in bracket now we put 11,8, then we say A, B, C. Now these are the variables that we are declaring. This 11 is what? The device code number. This 8 is the format specification number. So now it means that now after you have written it, now you now state the format. So now the format now is 8. This 8 here is the format. So format 8, format, then bracket. Now you can now state a particular format. This format specification number, you can actually state a particular format now that the computer would actually follow, okay, to arrange your variables. Like I told you, this is actually very practical. All right, this is very practical. So 11 here is the device code number, while 8 is the format specification number. A, B, and C are variables to store values. Now this 8 now in the read statement is the same as the one in the format specification, the format statement, as the statement number. Now like I told you, format specification number is also called the format statement number. All right, format statement number. So now you after you have outlined it like this, you come down, okay, and you now write the 8 and the format. Then in the bracket now you can now put a certain way you want the variables to be arranged. Okay, now if you look at this, there are 3 variables here. Okay, so you can say for instance now you say I4, okay, then let's say F6.1, okay, then you can say F8.2. I'm going to be explaining these examples. All right, now in this format statement, this F means real variables and I means I means integer variables. Now this I4 is how you would the kind of value that will be assigned to A. This F6.1 is the kind of value that will be assigned to B. F8.2 is the kind of value that will be assigned to C. These are examples, so you can actually assign your format statement for your variables in a different form. But let me explain these examples that I just gave. Okay, so like I said, you have your I4, you have your F6.1, you have F8.2. I've already explained device code number. Now I said that someone is asking, I said the first number here now is the device code number. Okay, you don't declare device code number, you just write it in the bracket. Device code number is the number. Under it now, you now write the format. Now these are the format that me have chosen. These are the format that I've actually chosen: I4, F6.1, F8.2. Now if you look at it now, you realize that there are three formats. Okay, the reason why there are three formats is because there are three variables, A, B, and C. That's why there are three formats. Now I'm going to be explaining what I4 means. Like I told you, I is for integer, F is for floating numbers, that is real numbers. Okay, so if you look at there are two arrangements for floating numbers, one arrangement for integer. So now basically I'm going to be explaining. Now in this format statement, F is for real, like I said, I is for integer. Now I4 means that the first variable, which is A, must be an integer variable that will not have more than 4 digits. It must have 4 digits. That it can only be any number from 0, 1, 2. Of course it will be whole numbers. That's what we mean by integers. Whole numbers. All right, whole numbers are integers. Okay, so first of all, it must be an integer, which means that it would only hold integer values. That's what this I4 means. All right, that's what this I4 means. Okay, so another thing, like I said, is that it must, the highest number of values that can be stored in this A will not exceed 4. For instance, now let's say 8,273. How many values are here? 4, right? It can also store 730. Okay, it can store 95. It can store 95. Do you get? It can store 95. It can store it can even store 2. Okay, so it means that it can only store from, let's say, from 0 to 9,999. You know that when it comes to 4 digits, this is like the highest 4 digits. After this is 10,000. After this is 10,000. Okay, so when we have I4, means that if, for instance, now if we have I5, let's say we have I5 as a format statement, we are saying that it cannot hold more than 5 digits. That's what it means. When it comes to real, it cannot hold more than 5 digits. It's very, very important to note that. So, but this one is I4. So we are saying that when you want to now assign values, when the compiler wants to assign values to variable A, it should not assign values that are more than 4 digits. So that's what it means. Then now let's go to this let's go to F6.1. F6.1. So now what does this F6.1 means? All right, like I told you, first of all, the F here is for what? Floating numbers. F is for floating numbers, or the real numbers. Floating numbers or real numbers. And real numbers are mostly decimals. All right, the floating numbers are decimals. Don't forget that. So decimals. So we are talking about decimals when we are talking about floating numbers. Okay, so if you look at B and C are all floating numbers. So now what it means is this. Okay, it means that, like I said, it must have a decimal point, and it must have a maximum. That is F6.1 must have a maximum of 4 digits as its whole number part, and a digit at its fractional part. A maximum of 4 digits as its whole number part, and 1 digit as its fractional part. When we say fractional part, we are talking about the part after the decimal point. The part after the what? Decimal point. Okay? So now look at watch what I mean here. Watch what I'm saying here. So what I'm saying here, remember, this F6.1 that I'm trying to analyze, right? This is a format I'm trying to analyze. Okay, so basically, like I said, it must hold a total of six entities. Okay, and after the decimal point must be only one. Now let me give an instance. Okay, let me give an example to this. Okay, now let's say we have something like let's say we have 4823.7. 4823.7. Okay, 4823.7. Now how many entities are here? Now it is 1 2 3 4 5 6. Now you're wondering, how is it 6? Are you not seeing you're wondering, are you not seeing 5 values here? Now the decimal point is also part of what you count. And what do we have after? How many values do we have after the decimal point? Just one value, right? Which is 7. What's one value? So when we say 6.1, first of all, you must know that it must have what? It must have what? 6. Everything, including the decimal point. Including decimal point. Decimal point is part of what you count. Then after the decimal point is one value. That's what we mean. It's one value. Another example is, let's say we have 2098.3. This is another example. Okay, this is another example. But it cannot have let's say 2839.42. 2839.42. First of all, count how many entities are here. 1 2 3 4 5 6 7. Right? 7 entities, right? So this one is F7.2. You know why it's F7.2? Because first of all, there are 7 entities here, and there are only 2 values after the decimal points. That's what it means. So this is the specification for this kind of value. Okay, let's say we have 29.3. How many entities are here? 1 2 3 4. Right? So this will be F4.1. Why is it 0.1? Why is it 1? Because we have only one value after the decimal point. Okay, so that's it. Now the next one is F8.2. An example of a value that can be assigned. What it means is that the decimal value must have 8 entities, and after the decimal point there will be only 2 values. For instance, so see what I want you to know. Okay, see the trick. Remember we had F8.2 there, right? F8.2. Look at the trick. The trick is this. The values here, the first value here is 8, right? The first value here is 8. Now, how do you do this? Now, to know the values that will come before the decimal point, now subtract the number of values after a decimal point and the decimal point itself. How many values after a decimal point? 2. Plus the decimal point itself, how many? 3. So 8 minus 3 is what? 8 minus 3 will give you 5. So it means that there will be 5 values before the decimal point. Okay, plus the decimal point giving you 6. Then 2 values after the decimal point. 6 plus 2 what? 8. Let me explain that again. Okay, the decimal point plus 2 is 3, right? Because remember, we're counting decimal point. Decimal point plus 2 is 3, right? And so subtract it from the highest number of values. So when we subtract 8 by 3, that is 8 minus 3, 5. So it means that we have 5 values, right? So we can say, let's say 42938.65. This is a typical example of this. Now let us count. 1 2 3 4 5 6 7 8. Are you seeing it? So we have a total of what? 8 values. We have a total of 8 values. The decimal point is also inclusive as the value. Also inclusive. So that's what format specification talks about. Like I told you, I talks about integers. So let's say something like I3. I3 is just whole numbers, 285. That is the maximum. It must be whole number. It can also store 53, but it should not exceed what? It should not exceed 3 digits.
floating numbers, these ones are decimals. These ones are decimals. So that's what it means. That's what format specification means. All right. So it means that like I said, it's how your variables should be arranged, the kind of values that should be assigned to your variables. Okay, maximum number of values. So the computer will not exceed, for A, when it is assigning a value in the specification part, it will not exceed more than what, 4 digits for A. It will not exceed what, more than 6 digits plus the decimal point and 1 value after the decimal point for B, as well as total of 8 digits as well as the decimal point, then 2 after the decimal point for C. All right. So that's it. Okay, so now I'm going to be giving you an exercise. You can type it in the comment box below. Now let's say, give an example. Give an example of, okay, now I will not ask you to give an example, rather I would write values now and ask you to write the format for it. Let's say we have 99.53. Okay, so what is the format for this? What type of format is this? What format is this? Now if we have, let's say, 6053, what format is this? This one, these two, these three. Let's say we have 41289.915. okay, what format is this? So this, and this. All right, these three. Okay, these three. Remember, I told you that this one is F8.2, right? F8.2. So basically, the total number here, 1 2 3 4 5, decimal point 6 7 8. F8 point, how many values after decimal point? 1 2. F8.2. okay, all right. Okay, so someone say F4.2. Good, that's correct. You're following. So try for the second one and the third one. If you're active, try for the second one. Okay, try for the second one and the third one. Okay, someone said I5. That's also correct as well. I5. Okay, so someone said F4.2. That's correct. And the same person said I5. This is also correct. Then how about the third one? I'm waiting for a response. Okay, nice one. Same person said F9.3. Okay, so F9, 1 2 3 4 5 6 7 8 9.3. So they are all correct. All right, impressive. I can see your responses. Okay, good, nice one. Nice responses. Now let's move forward. So we've talked about reads to an extent. Okay, okay. So basically we'll be looking at output statements now. Looking at output statements. Okay, looking at output statements. Now we have looked at input statement, and we say that Fortran uses reads as its input statement, and I've explained it in details. So now we'll be looking at output statement. Now Fortran uses writes. Fortran uses writes and prints. Yes, you're welcome. All right, let's proceed. So Fortran uses write and print as its output statement. Okay, now what is write statement? Write statement is used to send data to a display terminal for users to see. All right, so like I said, it's used to send what? Data to what we call a display terminal. All right, for users to see. Okay, to see. All right, you're all welcome. Okay, so it sends data to a display terminal for users to see. Okay, to see. So that's what the write statement does. So it's an output statement because it tries to ensure that there is a display of the results of that particular program that was being run. Okay, now
So that's what the write statement does. Then how about print? What does print statement do? Okay, what's the function of print statement? Now print statement has the same function as the write statement. All right, so print statement is the same as write statement. All right, same as write statement. Take note of that. So most times write and print tends to be used interchangeably. All right, tends to be used interchangeably. Okay, so Fortran uses 6 or 12 as its device code number for output. Okay, do you get that? So Fortran uses 6 or 12 as its what? Device code number. Just take note of that for output. But for input, the device code number for input is only specific for that particular device. That is for read, like I told you, is device specific. But either 6 or 12 is what the Fortran, formula translation Fortran, that uses as its what? Device what? Code number. Okay, so it's very important to know that. So, but in case you don't know your device code number, like I said, always use what? Asterisk. Always use asterisk. Okay, just as we did for read statement. So now let me give you the general form of the write statement and the print statement, the write and the print statement. All right, so write or print, we do it like this. We say write. Okay, we say write device df, then we have output lists. That is the list of the outputs. Okay, list of the output. So if you don't know device code number, or you don't want to use any format specification number, you say write, then use asterisk. Okay, then output what? Output list. Okay, the same thing is applicable to print. Okay, so you do the same thing for print, device code number, then f. But now one thing about print is that if you're not using the device code number and f, print tends to use only one asterisk, but you will not put it in bracket. Only one asterisk. That's for print. It's only write that uses double. Okay, read and write uses double. But print tends to use only one asterisk as far as using print. But like I said, both write and print performs the same function as what? Sending data to a display terminal for users to see. Then of course we have what? We have output what? Output lists. Lists. Okay, so this is the general form of the write and print statement. Okay, this is the general form of the write and print statement. For instance, now we can say write 12, 45. Okay, maybe 45 is the specification number, the format specification number. Okay, then we say let's say the output list can be x and y. Okay, output variables can be x and y. So basically the write statement is also used to display strings, not just numbers. Okay, used to display strings like statements, like characters. Okay, for instance, we can have something like this. You can say write asterisk, then you see something like I told you before. When you're writing strings, always put it in quotation mark. Always use a quotation mark, that is open and close quotes. All right, open and close quotes. So this will actually display this whatever you write here as the output list is what will display on the screen, on the output screen. This is what will display on the output screen. All right, so now we'll be going straight into writing simple programs. How can we write simple programs? Writing simple programs. So I'm going to be teaching you how to write simple Fortran programs. Okay, so now the first example we'll be looking at now I'll be giving you the first example 1. Okay, let's say we are told to write a program to calculate the sum of any two integers and display the result. All right, so we have write, let's say
we have write a program to calculate the sum of two integer numbers and display the results. Two integer numbers and display the results. All right, so now how do we navigate through this? Now we start by writing the program name. All right, we start by writing the program name. So we say, like I told you, you say program, then we can use two ints. Okay, we can say two ints or two integers. We can use something like this, say two integers as the program name. Then after you've written program and program name, the next thing you would have to write is implicit none. Okay, you write implicit none. Okay, so you write implicit none. Remember, I told you that implicit none, when I was giving you the basic structure of the Fortran program, I told you that implicit none, it forces the programmer to declare all variables, right? So you write implicit none. Then after you've written implicit none, okay, the next thing you would write is so what I say, this implicit none, if you look at it, I not write it on the same level as program. So you have to like shift, like let's say three spaces. Use the space bar, you shift like 3 spaces. Okay, shift like 3 spaces on below the program. So implicit none is spaced as well. You don't use this sign. Okay, you don't use this sign for implicit none. All right, you don't use that for implicit none. So implicit none is not together. You must space implicit none when you write implicit none. Okay, then now let's say you want to add, like you say, sum of two integer numbers. Okay, sum of two integer number. So it means that the data type that we will use will be integer. So we say integer. Remember how we declare integer, right? You say dot like this. Then after they say, let's say we want to use variables, say x, y, z. These are the variables. Let's say these are the variables we want to actually use, x, y, z. Okay. Now let's say that z is the answer. Like let's say that x and y. Okay, x and y are the variables that want to add, but we have to declare all. So let's say x plus y equals to z, then z is the result. Okay, then the next thing now is to use the write statement. Okay, you use the write statement. So you use write. I told you, since we don't know a specific data specific device code number to use, let's just put asterisk for safety. Now, so what you need to do, like I told you, I said something, that write statement uses strings. Okay, write statement uses strings. Now integer, this integer is, you can also write it on, you can also like give another like space as well. You can give a space as well under this implicit none. If you look now, this I is under m, you can also shift it. Okay, you should not be directly under implicit none. It should be shifted forward. Okay, it should be shifted forward. Okay, but from integer down, even right is under integer. Let me write it properly. This w is under integer. Okay, this w is under integer. So now when you have done the write, okay, now you use a statement. You say enter the value of the numbers. Enter the value of the numbers. Let me try and squeeze in here. Then you put end quote. Remember, when you're writing statement, open quotes, close quotes. So enter the value of the numbers as a write. Then after you have done your write, now this write you're doing here now is an output. All right, like I said, write is an output statement. Okay, it sends data to the display terminal for users to see. Now it sends this statement, enter the value. It sends a command. Then what does read does? Remember, I told you that read now imputes, okay, read now imputes a value, okay, assigns a value to the variables. Now look at what I remember what I said about read. Like I said, it's an executable statement, right? Don't forget that it's an executable statement, okay, which means that the major function of read is to what? Is to actually cause the Fortran compiler to do something, okay, to cause the Fortran compiler to do something, to perform a duty, So now, but this particular when you use this particular statement now, it's an output statement, okay. It's an output statement that would actually tell the Fortran compiler, okay, Fortran compiler what to display. You tell, okay, please display this, enter the value, more like an instruction. Then now after that, you now use the read statement, okay. Use your asterisk as well, okay. Then the read statement now is to now use the exact variables, is to now impute the exact variables that values to be assigned to, and the variables that values to be assigned to will be x, y. Those are the variables that, because it is x plus y that will give you z, right? So x and y are the variables that has to be added, that the integers that have to be added. Now these integers would be added after what? Values have been assigned to the word variables. Now the variables are x and y. So after the write statement, the read statement. So then now you now use your result, the result you're expecting, which is z. So you say something like that. Now you now state the formula. So you say z is equals to x plus y. Now this particular formula is what the Fortran compiler will use after assigning values. So for instance, now if x was given 5 and y was given 2, the Fortran compiler needs to know the formula to use. So after you have done your read statement and you have stated the exact formula, the exact variables that will be used in solving, then after that you now state the formula that will be used to achieve the required result, which I just did here. Then after that you bring your write statement, another write statement for output, okay. Now this write statement now will now state the result. So the result here is what? Z. So you just say z, okay. You just say z in the write statement. So you just write, then you say z, okay, because that's what you're looking for. Then after you have because at this point now it will display. So just like I said, this hello world, now when you write hello world, it's what will display. Enter the value of the numbers here, is what it will display. So it will display the value of the number, and it will store it inside x and y. Then it will now use this formula. After it has used the formula and so it will now display what? Z, based on the values that were actually assigned to these variables. Then after you have written this right, then you go and you end your program. You end program, you say end program at this point, okay. You say end program, and like I said, it must actually be on the same line like this. So you say two integers. End program must correlate here, must also correlate. They must be in sync here. Are you seeing how aligned it is? It should not be scattered. And the exact way you wrote your program name when you started should be the exact name you write your program name with when you end. All right, so it's very, very important. All right, so I believe this is clear. Okay, now remember, if you want to use formats, you can use format, okay. But you use format when you actually have, let's say, a format specification number in mind. Now, like I said, the format comes after the write, okay. The format comes after the write. For instance, now
if you want to write format, the format will come after this, right? Then you write the format. If you don't write format, it means that you just want the computer to just give any value the computer wishes. Like for instance, now here I did not give format because I want the computer to just enter any value at all, enter the value of the numbers, okay, enter any value at all, and display the result in any. You can see this Z7, you can actually write the format that you want this Z to be displayed. For instance, now I can come here and say, I can come here and write format I3. It means that the result should not be a value that is more than 3 digits. I can, if I want to specify the exact format that I want this X and Y to carry, after I have read the X and Y, before I even go and solve, I must write the format under. I must write the format underneath it. Okay, must write the format underneath it. All right, so it would now choose values that follows or that correlates with that particular format. Okay, all right, so I will be looking at another example of a program, so you familiarize yourself with them. Okay, all right, so okay, now let's move forward. So now let's say we have a question. Let's say write a program to calculate simple interest. I giving the principal P to be equal to 10,000, rate arrow to be equal to 5, and let's say time in bracket T to be equal to 2. Now if you look at it now, you realize that the difference between this particular program and the previous one is that here we are giving constants. Okay, remember what I said about like constant values. Okay, we are giving values that are assigned now to the variables. Okay, so now like I said, the first thing you have to do is to write your program. So it's a program, the program name, let's say simple interest. So simple underscore interest, simple interest. Then after that you say implicit none. Then after implicit none, remember, if you look at what we did here, okay, in the previous case, if you look at what we did, we use the data type to declare all the variables, because implicit none forces you to declare all variables. So we use data type integer. All right, we use data type integer because that's what we chose, because we know that because it was stated that integer numbers, right? So in this case now, it's a simple interest, giving principal and all of that. So now the reason why we are using real is because the real has a uniqueness. Real has a uniqueness for floating numbers, like I say decimals. So when you use the implicit none, the next thing that you do would be to use the data type. All right, so let's say real. Okay, so we want to declare the variables now. Let's say we have real. So remember, we'll put our double columns here. After we put our double columns, now we'll say P, R, T. Okay, P, R, T, I. These are the words. These are all the variables: principal, rate, time, interest. Okay, interest. Then after that, we use our write statement. So we say write, then asterisk, and we say in quotes, say assign values to what? To variables. Assign values to variables. This is the write statement. Okay, this is the write statement. Assign values to variables. Okay, that's our write statement. Then now, instead of using only read, now by the time we use our read,
we will now choose the variables that will be assigned, and the variables that will be assigned now will be p, arrow, and what, t. Okay, p, arrow, and t. Then we'll come down, since we already have the exact values that we need, instead of now just leaving it like this, we'll come down and we'll say, now remember, this reads, this arrow has to be under this w. Let me write it properly. Okay, this arrow here, everything just have to be straight like this. Okay, then what do? We'll come here, we'll say p equals to 10,000. This time, what we are doing here is constant declaration. Remember, I told you that we use equality sign for constant declaration. I explained it earlier. Now arrow is equals to what? Arrow is equals to 5. Yt is equals to what? 2. It's equal to 2. Okay, it's equal to 2. So the reason why you're writing this, if you look very well, we have nothing like that. After reading, then we just indicated our formula. Okay, we just indicated our formula. Look at the difference, because we do not have any value, particular value in mind for x and y. But now we have been told that the principal must be 10,000, the rate must be 5, and the time must be 2. Okay, but now this 5 now, this 5 now, because so the computer will be like wondering 5 what? Okay, remember, rate has to do with percent. Okay, so you put what we call a comment. This is used for comments. This sign, okay, this sign is used for, this is an exclamation mark, right? This is an exclamation mark. So we'll do that and we'll say percent. Then here, since this is time can actually be in different forms. Okay, we can have in seconds, we can have in minutes, we can have in hours, we can have in days, we can have in weeks, we can have in, but in this case now, you know, simple interest has to do with years. So we say years. All right, we say years. Okay, we say years. Then after we have done this, now we'll now use a statement. And that statement will also have a comment. Use the exclamation. So we'll do like this. We'll say exclamation calculate simple interest. Calculate simple interest. Now someone is asking there, now 5 years is spaced. 5 and this is spaced. They are not together. So calculate simple interest. All right. So now is at this point you now state the formula, and when you're stating the formula, you use remember I taught you Fortran statements. All right, you use Fortran statements. You will not just write it anyhow. Okay, so you come here, you say I. You remember the formula is I equals to PRT over 100, principal times rate times time over 100. But now you will not write it like that. You say I equals to P asterisk what, arrow asterisk T, put this in bracket, then slash 100. This is what the computer will understand. This is definitely what the computer will understand. So P asterisk arrow asterisk T slash 100. Remember this, if you didn't watch the initial video I made on formula translation, go and watch that video so you understand how I wrote this like this. This asterisk is for multiplication. Okay, you don't say I equals to P times arrow times T over 100. It's wrong. Okay, it's wrong. Now principal, okay, someone is asking, sir, what about P? Now there's no need writing anything alongside P. The reason why there's no need writing anything alongside P is that this P does not really have a unit. Okay, P can actually, you know, P normally has to do with the principal, which is more like a value in currency. It can be naira, it can be dollar, it can be pounds, it can be euros and all that. So since there is no specific value, there is no specific currency for the P, it's best you just leave it like it will not affect anything. But you cannot just say 5 without percent, because 5 is different from 5%. Okay, 5% is 5 over 100. You can't just say 2, because 2 seconds is different from 2 years. It's different from 2 minutes.
but 10,000 is 10,000. 10,000 is 10,000 because principal has to do with currency. So whatever answer you have would now be expressed based on your particular currency. I know 10,000 naira is not the same as $10,000. I know that. But basically, whatever answer you get will be based on your own currency, because this one does not really have a specific rate. You know how naira goes up, falls, dollar and naira, they tend to be parallel lines. Okay? But 5% will always be 5%. 2 years will always be 2 years. There's never a time that 2 years will become 2 days. All right, so that's why I did not put anything here for principal. Okay. So now, after you have stated this formula, now if you look at this part now, after stating the formula, what did we do? We'll now use the right statement and we'll state the result. So what is the result that we are expecting? So we'll say, what do we say here? We say right. We'll say right. Then after we say right, we use our double asterisk like this, and we say I. Double asterisk I. This is like the last thing. Before then, what we'll do is to end program. So under here, directly under here, we'll say end program. Then we'll come here and we'll say what? Simple interest. Simple interest. All right. So as you can see, so this is the program. This is the simple program for what? For simple interest. So if you are not giving values, there's no need writing all these things. After you have read PRT, next thing you will just come and after reading, you just state your formula, you write them. But now if you have values, you have to declare the constants. It's important that you declare the constants. All right, very important that you declare the constants. Okay. So in our next class, we'll be looking at control structures. In control structures, you see more advanced and complex programs. Okay, we have controls, we have loop, we have closed loop, that is loop structures, where we have do loop, we have do while, we have nested loop. Those are like examples of control structures that we'll be looking at in our next class tomorrow. Okay, so do well. You can go back to the beginning of this video and also still watch and get to understand how to write simple programs, and of course be very familiar with it. So this is where we would actually end this class. All right, so like I said, we also have another class, probably 1 or 2 more, to finish up the areas that are left to tackle in the course. Okay, so that's it basically. All right, that's it basically. Okay, let me give you an exercise. So write a program to calculate electrostatic force. Write a program to calculate electrostatic force. Electrostatic force. All right, the formula for electrostatic force is F equals to KQ1 Q2 all over R squared. So I'm not giving any value for this. I'm not giving you any value for this. All right, so write a program. You can send it to me on WhatsApp, okay, or you can just try it and keep it to yourself, anyone you choose. All right, so just attempt this. But in tomorrow's class, we'll be looking at much more complex programs under control structures. All right, much more complex programs under control structure. Then we'll be looking at arrays as well, how to write array programs and all of that. Okay, so this is what we'll be drawing the curtain for tonight's class. All right, you can do well to also share this video. This video will remain on the channel, so do well to rewatch. If you have any confusion, you have any question, you can feel free to ask. All right, you can send a message to me via WhatsApp. All right, and ask. Okay, I wrote my contacts in the previous video. You can go to that video and check my contact and text me if you have any question whatsoever. Share the video and enjoy the rest of your night. Okay, goodbye.